particular off the coast of Africa because there's a really huge temperature difference between the Sahara Desert and the colder Atlantic Ocean. So this is an example here of a spiral storm coming off the edge of the northern polar cap of Mars in winter. So this area here is the main part of the northern polar cap. This more diffuse area here is what we call the seasonal polar cap. So this is frost that comes and goes as the seasons change, and we'll talk about that more in a little bit. And then here you have the Sahara Desert, and then this storm that's basically lofting a bunch of sand off into the desert. And this is interesting because the storms over the Sahara can actually carry that dust all the way over to the Amazon, and they think that it might actually play a role in kind of keeping the rainforest the way that it is, and it's actually transplanting different types of materials into the Amazon, which is really cool. We also see a lot of frontal dust storms on Mars, which are really similar to frontal storms that you might see if you watch the weather reports here on Earth. They form the same way. You have heavy cold air pushing up lighter warm air really rapidly, and so you get this string of storms along the edge of this front, and it happens very quickly. They're really common in North America over winter, like right now. So this is an example of a storm over Utopia on Mars, one of those storm track areas just kind of overlaid on a map of the US. So the storm goes from here to here. So the front is larger than the whole United States north-south. We also get a lot of storms from slope winds, so places where you get things like, here you guys are probably familiar with things like Chinook winds. The same kind of thing can happen for places on Mars. So in this area here, this is a channel called Bovinda Vallis, which was probably carved by water maybe 3.5 or 4 billion years ago on Mars. And toward the south of the image here is a topographic high, and it's sloping in this direction. So this storm is moving toward the north. And if you can make it out, there's a little teeny tiny white dot right there next to that crater. That's actually a dust devil that's moving forward of the storm. So these are little tornado-like things that we tend to see, actually not in conjunction with dust storms on Mars, but every once in a while we'll see them around the outskirts. And this is one that we caught by accident because we were trying to get a stereo view of this valley. So we had an image a few days before this where it looked fine. Came back, tried to take this image to finish our stereo pair, because if you take two images from two different angles, you can get a 3D view of what that area looks like. But this storm got in the way. So we came back again a few days later, the storm was gone, finished our stereo pair. But every once in a while we'll catch these cool, unexpected views of storms, so they're not always bad. This is a close-up view of what these dust devils look like. This is a particularly large one from, it's very blown out on the screen. Basically, this is the dust devil, and this one extended something like 70 miles into the atmosphere. This is one of the tallest ones we've ever seen. And this dark area here is the shadow that's being cast onto the ground by this dust devil. This is a view from the HiRISE camera, the High Resolution Imaging Science Experiment, which takes pictures at 25 centimeters per pixel, which means you can resolve things about 75 centimeters large on the ground on Mars. We can image the rovers, we can see the tracks of the rovers, we can see large boulders to make sure we're not going to drive on them or land on top of them. It's a really amazing camera. We've also seen some of these dust devils from the ground. This is one of the coolest images that we've ever gotten, I think, from Mars. These are tracks from the Opportunity rover going off into the distance. Again, I'm not really sure why it's so blown out on the screen. But here is a dust devil, and then the shadow behind it from the dust devil, traveling in the opposite direction. And we've even caught these in motion. So this is a video from Spirit from 2006, I think it was. And the little counter in the bottom corner is in seconds, I believe, from the time of the beginning of this video. So there's the main one you'll see in the foreground, and then you'll see kind of a couple right there pop up in the background. This one is just super cool. I love this video so much. I think we knew that there were dust devils in the area because anytime that we would see a spike in our power, we would know that wind had come by and cleaned off the solar panels, and so we're like, oh, there must be dust storms happening. And they always happen kind of in the same time of year, so we're like, let's see if we can catch them. And we managed to capture a few different videos of the dust devils going by, which is really cool. I love anything that helps reinforce the idea that Mars is an active place. It's not just this dead rock out in space. There's stuff happening on it all the time, which I don't think we really had a good appreciation for before Mars Global Surveyor and Mars Reconnaissance Orbiter got there. Our view of Mars completely changed between the Viking orbiters and Mars Global Surveyor. And then with cameras like HiRISE, which took the dust devil image, and then these images here, it's also completely revolutionized our view of Mars. So these are all tracks that are actually left behind when these dust devils move across the surface. It's because, like I said before, the darker areas of Mars tend to be the places that are not very dusty, and then the lighter areas are dusty. So when you hear that Mars is the red planet, it's actually kind of a lie, because Mars is actually blackish gray underneath all that dust. It looks more like the moon or Mercury. But on top of that is all of this basically rusted dust. So you have basically iron that is not oxidized underneath oxidized rusty iron. So when you blow away that dust, you can actually see the true colors of Mars. So when these dust devils come by, they blow all the dust out of the way, and they leave these really artistic streaks behind them, so we can see what Mars looks like beneath everything. We also see really cool tiny storms sometimes too. So this is an area called Amazonas Planitia that gets dust storms on a pretty regular basis, so we monitor this particular area to look for these storms. This is about 30 kilometers across, and these are streamers of dust that are actually being lofted off the surface, and then it reaches some point in the atmosphere where they then kind of diffuse and then fall back down. And we capture these in a few different areas too. This is another example of streamers over Claritas Fossae. So these are streamers coming in this direction instead of blowing this direction, like in the previous image. And sometimes we can even catch views of this stuff in motion. So this is from, that's a great reaction. So these are views from the European Mars Express spacecraft, which has been at Mars since 2003. And it has this really strange elliptical orbit where it takes stereo images or 3D images with a really small time difference between them. So we can capture activity on Mars at a really small time scale. So this is just over the course of a few minutes of these streamers of dust lifting off the surface in color, which is also amazing. Yeah, it does kind of look like forest fire. I'm gonna change the slide now for the people that have their phones up, sorry. But less well known than the dust storms are water ice clouds on Mars. And this is a really cool limb view of Mars, again from the Mars Express spacecraft, showing the edge of the atmosphere. And the atmosphere is Ascraeus Mons, one of the big volcanoes on Mars. Just kind of sticking out there. But the water ice clouds are usually really prominent because they stand out color-wise in both the mock images and the Marcy images from dust storms. In the mock images, the older data set, they tend to look kind of white like these, and in Marcy and Mars Express data, they tend to be really blue just because of the wavelengths that we're imaging them with. There are a lot of different types of these clouds. We won't go through all of them just because there's a lot, but this is just kind of a list, and we'll go through some pretty examples of them before. So the biggest type that we tend to see are orographic clouds, and since you guys live in a place where there are mountains, this doesn't work as well when I give this presentation in places like Toronto, because people there don't know what a mountain is. But here we get clouds over the tops of volcanoes. So when you look at Mount Hood and you have like those nice lenticular clouds over the top, or you have weather systems that are just hanging out over the mountain, this is what happens on Mars over these big volcanoes. So this is Olympus Mons. These are 3 smaller volcanoes collectively referred to as the Tharsis Montes. And this one is 3 times taller than Mount Everest. These ones are not that much shorter, but they're so tall that they cause all these little weather systems around them. I think in the days of Vikings, some of these people thought these might have been evidence of the volcanoes erupting, but they're not because they're stationary and they stay there over the course of like entire seasons, so usually during spring and summer. And this is because of an effect that we'll show in a couple of slides. This is another example of some orographic clouds over, again, Syrtis Major. This is a very prominent area on Mars, we've talked about it a lot. Since this one is from Marcy, they look more blue than in the previous image. And these are really similar to cirrus clouds on Earth. So these really high altitude, wispy clouds that are made up of water ice crystals. So the water in the Martian atmosphere is generally not water vapor because it's too cold and the pressure is too low. These things are hanging around in the form of little tiny ice crystals instead. Another case of weather on Mars that made a lot of news last year were these aster clouds that tend to hang out particularly over this volcano here, RCAMeeting. And these ones do kind of look like the volcano is erupting. A lot of people thought when this came out from Mars Express last year that this volcano was erupting, but it's not. It's a water ice cloud that tends to hang out here and forms these really long streaks back from the volcano in the direction of the wind going. And it's just in the daytime due to these upslope winds blowing up the slopes of the volcano, and then it causes these big streamers behind them. And for some reason, just based on where this particular volcano is on Mars and circulation patterns, they hang out around this one really well. The other volcanoes, they tend to dissipate out a lot. But when I was trying to prove to people on Twitter that this was not the volcano erupting, we see it all the time, I was trying to show them another example. This is from India's Mars Orbiter mission. So India has a mission at Mars right now that is taking some really beautiful color images of the planet. That again, we don't see too often, but a lot of them are out there on social media, especially on the Planetary Society's website. Emily Lactowala, who I guess spoke to you guys recently, she's been processing a lot of their images to get them out there to people, which is really great. But a lot of these things tend to hang out over the volcanoes because they're in the equatorial regions due to a feature called the aphelion cloud belt. And this is something that forms in spring and summer because you have all of the water from the seasonal polar caps. It ends up sublimating. It goes directly from solid frost on the surface to vapor or ice particles in the atmosphere. And it starts to circulate back down toward the equator, but the Martian atmosphere is so thin that it can't hold all of that, so it starts to condense out in the form of clouds. So all of the wispy blue things you see on here are water ice clouds, and they tend to hang out over sort of the equatorial region and the tropics, and then you can compare them to like these pinkish areas, which are the dust storms. So they look very different from each other when we're trying to monitor the different types of weather on a planet. We also see these Lee waves or gravity wave clouds, again, something very common in places like the Pacific Northwest, near Mount Hood and Mount Rainier, where you have wind kind of moving over these tall mountains. On Mars, we tend to see them in the wake of really large impact craters because the rims of these craters are so large, they're basically mountain ranges, just in the form of circles. So they can extend really far off behind them. And you basically just need enough of a vertical disturbance in the atmosphere to create these little parcels of air that form these waves behind them. There's another really dramatic feature that you can actually see again through telescopes here on Earth called the North Polar Hood. And this forms from a series of storms that all kind of coalesce together in late summer moving into fall. And it ends up completely covering the northern polar cap from view until midwinter. And then at that point, the northern polar cap is on the night side of the planet, so we can't actually see it again until it comes out in springtime. And at that point, that entire mass of water vapor or water ice in the atmosphere ends up depositing onto the surface as frost. So this is what it looks like from orbit before it moves over to the night side of the planet. This is the North Polar Hood, and then these are some dust storms kind of spiraling off it, like those storms we saw earlier. And then this is a view from a telescope on Earth. I think this is a 16-inch telescope. You can kind of see the clouds here hanging out. So this one has been flipped, so it's actually up. And the cap ends up changing quite significantly between winter and spring and summer. So like I said, in winter, the northern polar cap is on the night side of the planet. We can't see it. So what we tend to do is we try to get a snapshot at the very beginning of spring when it first comes onto the day side of the planet, so we get a close idea of what it looked like during winter. So this is the northern polar cap from the Mars Rover camera in early spring, so like as soon as we could image it, and this is what it looks like in summer. So there's a pretty significant difference for what it looks like. This stuff that hangs around year after year is called the residual polar cap. We used to call it the permanent polar cap until we saw that the south polar cap was disappearing, and then we realized we had to change the name a little bit. And then all of this stuff that goes away and comes back year after year is the seasonal polar cap. And this is just frost that comes and goes. We also see a lot of fog on Mars, and this is something that we weren't able to observe for a while because it tends to form in the morning, and we have a lot of our orbiters in what's called a PM orbit. So it crosses whatever it's looking at on the surface at like 3 or 4 p.m. And once we moved some of our orbiters into an AM orbit, so we were passing over things at like 10 a.m., we started seeing fog in certain places. So this is part of Valles Marineris, just filled with fog. And the types of fog that we see on Earth and Mars are exactly the same. So we have advective fog, which forms when you have humid air moving over cold ground, or vice versa. You have radiative fog when you have fog that forms really close to the ground due to radiational cooling of the ground, so that's really common in like the Bay Area. And then upslope fog that forms due to circulation going up the sides of slopes. So sometimes we see that kind of hanging around the edges of the volcanoes if we catch them early enough in the morning. So a nice thing about Mars is that the weather is super, super predictable because we don't have oceans, we don't have humans, so it's really, well, I guess there are a few robots, but the robots are not significant enough to affect the weather. So we can predict the weather on Mars on pretty much a week-by-week basis. And when I was working on the team for the Marcy camera, we would actually meet every week and go through what the weather was going to be like for the next week or two, so we could plan out our imaging of the surface and also plan out the operations for the rovers. So we have a pretty good idea of when things are going to happen and where they're going to happen pretty reliably, which is really amazing. So in northern spring, we'll just kind of start there because that's Elsevest 0 from our calendar markers. This is when you get that aphelion cloud belt, so that belt of water ice clouds that tends to hang out around the equator and over the tops of the large volcanoes. So these are all views from the Mars Orbiter camera, the older one. So here's water ice clouds hanging out over all the big volcanoes, and we can watch the the North Polar Cap shrink as we go from the beginning of spring toward the end of spring. This is a very dramatic change over this course of time. We also start to see daily dust storm activity along the edge of the cap as it's receding, again because of that temperature difference between the area with frost and the area that is not frosty. At the same time of year, it's fall in the southern hemisphere. In fall, it's kind of a boring place weather-wise on Mars, which is really good. The dust storm activity is at a minimum because there's not as big of a temperature difference between the icy places and the not icy places. And we see some frost deposited on the surface, but not a lot compared to when it's actually going into winter. Moving forward into northern summer, this is when we have the global peak in water ice cloud cover because you've had the most sublimation of that northern seasonal cap. All that water has to go somewhere and it ends up condensing out in the form of these clouds. And at this point, all you have left is this perennial cap, so that little tiny bit that was hanging around year after year. This is when we start to get those northern polar spiral storms. And again, they can be really dramatic. So this is another example of an area over the northern polar cap where it's not stormy versus one of these spiral storms encompassing the entire polar cap. So again, these are absolutely massive storms. These can get to a point where they completely obscure the sky over the northern polar cap for weeks at a time, and they're really, really problematic for trying to image not only the cap, but the northern high latitudes around them too, because we just can't see through the dust with the cameras we have in orbit. For any camera nerds, it's the signal to noise ratio is not good enough on a lot of the cameras, so the dust just really gets in the way. Meanwhile, in winter, this is when you're starting to get a lot of dust storm activity along the edge of the seasonal southern polar cap, because it also has a lot of frost deposition around it when you move into winter, like the northern cap. But this frost is generally made up more of carbon dioxide ice than water ice. The carbon dioxide doesn't really affect a lot of the weather patterns, which is why we didn't talk about it very much in this particular presentation, but it does affect the frost deposition on the surface. This is also when the southern polar cap reaches its northernmost extent. So when you're at the peak of winter in the southern hemisphere, that seasonal cap extends all the way up to about 30 degrees latitude in the southern hemisphere. In the northern hemisphere, the seasonal cap only tends to get to about 54 degrees, and it's just because of differences in elevation. The southern hemisphere is much higher elevation, so it's much colder at that time of year than when you have winter in the northern hemisphere when that cap is being deposited onto the surface. In fall in the northern hemisphere, this is when you get that north polar hood that's forming from all those spiral storms coalescing. And this is when you start to get the large dust storms and the possibility for the global events, the planet-encircling dust events. Because you have these spiral storms going off and going down these storm tracks with the potential for going down and hitting the edge of the south polar cap here. So this is an example from the 2001 global event where we had on Elsevest 180, between then and 205 the storm hit, so this is about a month and a half difference or something like that. And here again, all you can really make out on the surface are the peaks of the tall volcanoes. In southern spring, you have the potential for these regional dust storms if you get those storms moving across the equator from the northern hemisphere into the southern hemisphere. We don't tend to get a lot that start in the southern hemisphere this time of year, except right along the edge of the polar cap as it's retreating because you're moving towards summertime. And you tend to get a lot of dust and fog just kind of hanging out in Valles Marineris at this time of year because it's a gigantic hole in the ground, and so stuff goes in there and it sits there and it just waits until you basically get flushing winds to come through and push all of that dust and the clouds out of there. And this is when we start to see a lot of the retreat of the southern polar cap. So it starts out like this at the end of winter and looks like this by the time you hit the end of spring. The size difference in the change of the southern polar cap is much more dramatic than it is in the northern polar cap. Then in northern winter, this is when you still have some sporadic dust storms going on, again because of these temperature differences. You have another smaller round of potential global storms. So you have these spiral storms coming off, but they're much less likely to become global events. I think we've had a couple of that we've observed, or at least ones that got to be really large, but not quite global in this time of year. But it's another time that we keep an eye out just in case something might be going wrong. And this is when the northern polar cap reaches its southernmost extent. And then we get the water ice clouds forming over the tops of large volcanoes, again, just because they're so tall. And we get a lot of ground fog in Valles Marineris because of the temperature differences that you have inside that big gash in the middle of the planet. As we move into southern summer, you have even more retreat of the southern polar cap, so it gets really, really tiny. So this is the beginning of summer versus the very end of summer. There's not a whole lot of the cap left. The changes that we're seeing in the actual climate change of the southern polar cap of Mars are too small scale to see in these images. It's more like individual scarps that are changing. But we found that by accident by trying to do stereo coverage of places of the southern polar cap of Mars back in 1997 or so. And the person at the company that I used to work for was trying to line them up, and they were not triangulating with each other. And after lots of swearing at the computer and beating on the screen and wondering why it wasn't working, we realized that it was because the images themselves were taking pictures of features that were changing. And so they couldn't line up with each other anymore. So it was a complete accidental discovery, basically by the IT guy at this company. And now he has his name on a science paper. And we've been monitoring this ever since. So we monitor the southern polar cap of Mars every single year to watch how much it's receding, to try and understand why this change is happening. I like to end this talk with this really cool video that was never actually released by NASA, but it's a year worth of compilation of Marcy images to show a typical year of weather on Mars, corresponding with the 2007 global dust event that we had. So the places where you see black are just places where the camera couldn't operate because we had slewed the spacecraft too much for some other observations, so we're not trying to hide anything in there. And then the green and the pink areas are places where the different wavelengths that this particular camera images at don't quite line up with that fisheye lens. So there's nothing on Mars that's actually bright pink or bright green. It's just a particular artifact of the way this camera works. That was a cosmic ray hit when it all turned pink. That was a weird day. So it's kind of hard to see in some places when we lose a lot of coverage, but there is where the global dust storm started. So this video plays out longer than the one that you saw before, so we can actually watch it dissipate more. And it's kind of cool because you can also watch, here, we're in northern winter, so you can't actually see the northern polar cap. It's on the night side of the planet, and then we can see the south pole because this is the middle of, we're in southern spring, summer down here. So you can see it. But as time is changing, you can see here, the edge of the image is creeping north, and now the south pole is on the night side of the planet, and we can see up where the north pole is. There's all these storms going along here along the edge of the seasonal northern polar cap. So the white and blue kind of areas are the water ice clouds. And then there's a lot of dust storms kind of hanging out here in Utopia Planitia. There's some you'll see, like that one, flushing through Acidalia. There's some along here because one of the storm activity areas that I didn't really talk about is that there's also a temperature difference between the day side and the night side of the planet, so along the area that we call the Terminator, and so that causes a lot of weather activity too. So there's some dust storms along here through the day-night Terminator. Interestingly, that also causes weather on the moon because you get temperature differences that cause electrostatic differences in the dust. And so dust will move from the day side to the night side of the moon in these little tiny dust storms, even though it doesn't really have much of an atmosphere. So here we're kind of moving into the aphelion cloud belt season, so lots and lots of water ice clouds hanging out here, some dust storms, big dust storm right here, and the polar cap is on the night side of the planet down here. So that's just kind of what a year of weather looks like on Mars. I'd love to someday put together an animation of this for all of the data that we have for Marcy, but this data is really difficult to work with, and there's a lot of it, so that might take a long time. So the takeaway point from this is Mars Mars is a really dynamic place. There's a lot of weather. It's going on all the time. It's not a dead rock just hanging out there. It's got clouds made up of dust and water ice. It has fog. It has dust devils. There's stuff happening constantly. And so it's a really exciting place to watch and learn about weather. And since we don't have things in the loop like humans and oceans, it actually helps us understand some of these weather patterns a little bit more because you have less things factoring into them. So it's a really cool thing to study. And if you're interested in looking at the weather on Mars yourself, let's see if I still have this slide. The company that built the Marcy camera, Mainland Space Science Systems, has a website, and if you go to their main page and click on this area here that says latest Martian weather, you can actually get a weather report for the previous week on Mars, along with a little spinning video of the Marcy data from the previous week. It usually focuses on areas where the rovers are, so you can see what the rovers have been experiencing in the skies above them, and just anything cool like, oh, we saw a huge dust storm in Utopia, or there's a lot of dust hanging out over Curiosity. So it's kind of cool if you're really excited about that kind of stuff. They also just have a lot of really cool images from the Mars Orbiter camera, some from Mars Reconnaissance Orbiter. There's a lot of cool data you can pour through on their website. With that, if you guys have any questions about Mars or weather on Mars specifically, I'm not an expert on weather, I will try to answer them right now and leave you with this beautiful view of sunset on Mars from the Curiosity.